We have already studied how to take factors of numbers. So in this lecture, we are going to see how to find the highest common factor, HCF, or the greatest common divisor, GCD, of two or more than two numbers. So let's take the example of 36 and 48. And let's say we are asked to find what is the HCF or GCD of 36 and 48. And later on in the upcoming lectures, we are going to see what is the actual meaning of this HCF or GCD. Let's start with the factors of 36. We know 36 comes in the table of 1 and 36. 1 36 are 36. Then 2 18s are 36. Then we have 3 12s are 36. Then 4 9s are 36 and 6 6 are 36. So the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. Similarly, we are going to list down the factors of 48. 1, 2, 3, 4, 6, 8, 12, 16, 24 and 48. And then we are going to write down what are the common factors or the common divisors. We're going to write down the common factors of 36 and 48. So we know both the numbers have 1 as a common factor, then 2 as a common factor, then 3 also as a common factor, 4 as a common factor. Just find the numbers which are common to both the list. Then 6, then we do not have 9, we do not have 8, then we have 12, then we do not have 18, and we do not have 36. So the common factors of 36 and 48 are 1, 2, 3, 4, 6 and 12. So pick up any number from here, let's say 3, and in the table of 3 you will get 36 as well as 48. In the table of 6 you are going to get 36 and 48. In the table of 12 also. So what is the highest common factor? The HCF, or the greatest common divisor, the GCD. The biggest number in this list of common factors, the highest number, the biggest number, the greatest number, and that is 12. So 12 is the HCF or the GCD of 36 and 48. So now we are going to learn certain methods to find out HCF or GCD, and then you can see which method you like the most. So the method number 1 is listing all the factors, the one that we just saw. We are going to take another example now. So let's write the factors of 56, 24 and 72 and then find which is the biggest possible number in the table of which you get 56, 24 as well as 72. So let's start with the factors of 56. We know 56 goes in the table of 1 as well as 56. Then it goes in the table of 2, yes, because the last digit is even. And we know 2 28s are 56. If you just don't know, just you can divide it in the corner. And then does this go in the table of 3? 5 plus 6 is 11. 5 plus 6 is 11. 11 does not go in the table of 3, so this will not go in the table of 3. What about 4? Let's divide this in the corner. So we have 4 ones are 4. And yeah, 4 4s are 16. It goes in the table of 4. So it's 4 14s are 56. Does this go in the table of 5? No. Does this go in the table of 6? The answer is no, because it goes in the table of 2, but it does not go in the table of 3. So it does not go in the table of 6. Does this go in the table of 7? Yes, 7 8s are 56. So we have 7 and 8. And since these two are consecutive numbers, we have all the factors of 56 before us. What about 24? 24 goes in the table of 1 and 24 itself. Then it goes in the table of 2 and 12. 2 12s are 24. Then it goes in the table of 3. 2 plus 4 is 6. Yes, it goes in the table of 3. 3 8s are 24. That's right. 3 8s are 24. Does this go in the table of 4? 4 6s are 24. That's right. 4 6 are 24, and only number that comes over here is 5, and no, it does not go in the table of 5. So all these are the factors of 24. What about 72? 72 goes in the table of 1 and 72 itself. Then it's an even number, so it will go in the table of 2. So 2 3s are 6 and 2 6 are 12. It goes in the table of 36. Then we have 3. So 7 plus 2 is 9. Yeah, it goes in the table of 3. It goes in the table of 3. And let's divide this in the corner. So 3 2s are 6. 1 remainder, 2. 3 4s are 12. So 3 24s are 72. Does this go in the table of 4? Let's see. The last 2 digits should be divisible. So 4 ones are 4, 3, 2, 4 8s are 32. This goes in the table of 4. So 4 18s are. Now we are in search of all the numbers between 4 and 18. So let's check 5. No, it will not go in the table of 5. What about 6? It goes in the table of 2. It goes in the table of 3. So it will definitely go in the table of 6. I'll just make some room over here. Yeah. And let's divide this by 6. 72 divided by 6. 6 1s are 6. And 6 2s are 12. So 6 12s are 72. Then what about 7? 7 8s are 56, 7 9s are 63, 7 10s are 70, 7 11s are 77. It will not go in the table of 7. What about 8? Yeah, 8 9s are 72. So it goes in the table of 8 as well as 9. Just write this properly so that everyone can see this. So all these are the factors of 72. Now we are interested in finding what is the highest common factor. So first of all, let us list down the common factors. Common factors. So we know 1 is the common factor. So whatever happens, 1 will at least be a common factor in all the numbers. So then we have 2 in all the 3 of them. Remember, you should have a common factor in all the 3. For instance, 3 belongs to this list and this list, but 3 does not belong to the first list. So we are not going to write 3. What about 4? Yes, 4 is present in all the 3 lists. So 4 is a common factor. Then we cannot write 7. What about 8? Yeah, 8 is present in all the 3 lists. So 8 is also a common factor. What about 14? 14 is not present over here. What about 28? 28 is not present over here. 56 not present. So we do not have any other numbers which is present in all the 3 lists. Someone may say that we have 24 over here, but we do not have 24 in the first list. So what is the HCF? So HCF is the biggest number from the common factors, and therefore the HCF is 8. And yes, 8 is present in all the 3 list of factors of all the numbers. Then we have another method, which is method number 2, and that is by prime factorization. So what we are going to do is, we are going to see the same example and see for ourselves that we get 8 as the answer over here also, but using the prime factorization method. So we're going to find the prime factors of 56, then 24, then 72. And in order to find the prime factors of 56, we are going to factorize it in the corner. So 2 2s are 4, 1 is the remainder, 1 6 16, 2 8s are 16. For those who are wondering, this is the same as dividing 56 by 2. So 2 2s are 4, and the 1 remainder is written over here, and we bring down the 6 and we see this as 16, and over here we see this as 16 only. So 2 8s are 60, and we have a 0 remainder. So we write this as a shorthand, so that we do not spend a lot of space. So then this is also even, so it's divisible by 2. 2 1s are 2, 2 4s are 8. Then we have 2 7s are 14, and then we have 7 1s are 7. So the prime factors of 56 are 2 multiplied by 2 multiplied by 2 multiplied by 7. Then we're going to find the prime factors of 24. So same way, 24, 2 1s are 2, 2 2s are 4, 2 6 are 12, 2 3s are 6, 3 1s are 3. So we have 2 multiplied by 2 multiplied by 2 multiplied by 3. And finally, we'll find the prime factors of 72. So We'll start with 2. 2 3s are 6, because 2 4s are 8 will become a little bigger. So 2 3s are 6, we have 1 remainder, 12. 2 6 are 12. Then we have 2, 2 1s are 2, 2 8s are 16. Then we have 2 9s are 18. Then we have 3, 3 3s are 9, and then 3 1s are 3. So the prime factors of 72 are 2, 2, 2, 3, 3. Okay, now what? How are we going to find the HCF? So first of all, we are going to underline all the numbers that are common in all the 3. For example, 2 is common to all the 3. Then we have another 2 common to all the 3. Then we have another 2 common to all the 3. And then 7 is not common, 3 is common only to the last 2 numbers. So we are going to write the common factors, or directly we can write down the HCF. So the highest common factor is 2 multiplied by 2 multiplied by 2. We are not going to write this 2 more times. We are only going to write this 1 time. So 2 multiplied by 2 multiplied by 2, or this 2 multiplied by 2 multiplied by 2. So we have 8. So 8 is the HCF. I prefer this method to the other methods because this is a bit faster method than listing down all the factors.